Hi, in this video, we're going to continue talking about linked local addresses. We're actually going to talk about how they are automatically created using EUI 64, randomly generated, and the IPv6 enable command. So let's get started. So linked local addresses are created automatically, either using FE80, usually as the first 10 bits, and then an interface ID. That interface ID can use EUI 64, which we'll talk about in a moment, excuse me, which is what Cisco routers use, or a random 64 bits, which many host operating systems use, such as Windows. They can also be configured manually. This is common practice only for routers. Other devices, we really don't care that the automatic creation is fine. We'll talk about why routers usually should have their linked local addresses configured manually in a little later. There's another way that linked local addresses can be generated automatically, known as CGA, cryptographically generated addresses. I'm not going to go into that here. It's not very common, but anyway, let's go ahead and continue. So on a router, on a Cisco router, if I do show interface gigabit 0/0, I can see the MAC address, the Ethernet MAC address, also known as the BIA, burned in address, 48-bit address. If I do show IPv6 interface gigabit 00, I can actually see the IPv6 addresses on that device. Here I see my link local address. Do you notice a relationship between the link local address and the Ethernet MAC address? Okay. You might notice that the link local address on Cisco iOS looks very similar to this MAC address. There's that DA0093. It's got something else in it. We'll talk about what these bits are, or these hexadecimal digits are, and this here, but it looks very similar. That's because the Cisco iOS, when it creates the link local addresses, uses a process called EUI 64. EUI 64 uses the MAC address, the Ethernet MAC address, to generate the link local address. Okay. So as we'll see, it takes the 48-bit MAC address and it's got to turn it into a 64-bit interface ID. So it does that by inserting another 16 bits, FFFE and hex. We're going to see this process in a moment. And it flips one of the bits called the universal local bit. So let's take a look. Here's the MAC address on that Ethernet interface. Okay. So we have an organizationally unique identifier, which is 24 bits. We have a device identifier, if I can say that, which is 24 bits. This is the unique part here, this last 24 bits, unique to the OUI. Okay, so what does EUI 64 do? Well, it divides that up, splits them up, and inserts 16 bits. So that's where we get the 64-bit identifier for interface ID is what I was trying to say. 64-bit interface ID. This is FFFE, but we're not quite done yet. What EUI 64 also does is it takes that 7th bit and actually flips it. It's known as the universal local bit. And there's kind of a history behind that that's actually not important, but it does get flipped. And that's why you'll see that the second hexadecimal digit actually gets changed, in this case from an 8 to an A. Okay, so there's our MAC address, and there is our link local address. And we can see that it's actually based on EUI 64 because it has FFFE in the middle. And we notice that 8th bit got flipped. Okay. We see gigabit 01 also uses its MAC address to create its link local address, EUI 64. Whenever we see FFFE in the middle, it's very, 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 very good chances are that that's its EUI 64, that it wasn't randomly created, although it could happen, but probably not. Wait a minute, that's serial interface. The serial interfaces don't have MAC addresses. That's okay. Serial interface will use the MAC address, usually of one of its Ethernet interfaces. In this case, it's using, notice the link local address of serial 000 is identical to the link local address of gigabit Ethernet 0/0. Then wait a minute, you think, but they have the same link local address. Two interfaces with different link local addresses, is that a problem? No. Remember, link local addresses only have to be unique on the link. Okay, so let's verify link local addresses. So let's take a look at some different ways to do this. Let's look at a Linux PC over here on the right. I do ifconfig. When I do ifconfig, it shows me the MAC address right here, hardware address. And down here, I see the link local address, FE80. And notice there's FFFE in the middle. So on this Linux operating system that I happen to be running at the time, it does use EUI 64 to create its link local address automatically. Okay? So you'll notice the 0 got changed to a 2. That's the second hex digit. There's, remember the omitting, we have a 0 here that's omitted. Okay, so that's the red 0 is actually in front here. And then the second 0 got changed to a 2 because we flipped that 8th bit. Okay, so there, that's showing you from the book the EUI 64 format of the Linux PC and how that all got created. Okay, well, what about Windows? Does it use EUI 64? No, Windows by default, the later operating systems, uses a randomly generated number. Okay, so we take a look at the link local address here. And before I go to the zone ID, notice that there is no FFFE in the middle. Matter of fact, and notice this interface ID has nothing to do with the physical address. This is the MAC address. You ipconfig/all, you see the MAC address. But notice the link local address has nothing to do, the interface ID portion of the link local address, nothing to do with the MAC address. All right, what about that thing at the end? What, %11? Where'd that come from? That's known as a zone ID. Okay, so a zone ID. Many operating systems, typically host operating systems, Windows, Linux, Mac OS, use something called a zone ID at the end, a % and a number. Okay? It helps determine which interface to use when sending packets destined for that link local address. I'll show you an example in a moment. It's important when a device has multiple interfaces. A device might have an Ethernet interface and a wireless NIC as well. Okay. So the zone ID is only locally significant. It's only for that device. Has nothing to do, other devices may use different zone IDs. Every device has its own, creates its own zone ID. We'll see how this is used in a moment. So a computer with two interfaces, like a Ethernet wired interface and a wireless interface, may have two different link local addresses, okay? And we'll have two different zone IDs. So we'll take a look at how this is used here in a moment. Let me get past all this. Let me just mention Linux and Mac OS use a %ETH or ENMAC followed by the zone ID or interface scope value. Well, we'll see how this is used in a moment. All right, let's get started. Let me kind of show you all this. So here's a Windows device. If I do IP config, and let's say I have a wireless NIC and an Ethernet NIC, okay, notice that over here is my zone ID. Okay. Now, I have a default gateway. We'll talk about that in a moment. That's the link local address of the router. Okay. And notice that the router has, it's the same link local address for both, but different zone IDs. All right, so our wireless LAN adapter, okay, we can see it has %12 here for all the zone IDs having to do with the wireless LAN. For wired Ethernet, this device is using %11. Okay, let's take a look at how we can also see these zone IDs. If I do NetSH interface, IPv6 show interfaces, you can try this on your Windows device. If you have a Windows computer, try this. Very cool. You'll see the zone IDs associated with your machine. So on mine, 12 is wireless network connection, the wireless LAN. 11 is the local area connection. Okay. So as we can see here, 12 and 11. Now, also notice I have two different link local addresses. One for my wireless LAN and one for my Ethernet NIC. Okay, my machine has two different link local addresses. Okay, well, what if I want, on Windows, what if I want to ping another device? Okay, so let's say I want to ping the router's default gateway. So let me go back here. I'm going to ping this address here on the router. Okay. Now, the router, the same default gateway address, but notice one is the wireless connection, one's the wireless. Okay, so I'm going to ping that address. This is the router's link local address. Okay. But I'm going to use two different zone IDs. Here I'm using %11. Here I'm using %12. Okay. And if we remember, let's go back one more time here. We remember %12 is the wireless, %11 is the local area network. Also shows us right down here. Okay. So here I'm pinging the wired link local address on the router. Here I'm pinging the wireless link local address on the router. Same, notice it's the same address, but one is on the wired, one is on the wired and one is on the wireless. So %11 is the wired, %12 is the wireless. You'll also notice it shows me here that when I get the replies, I'm getting the reply back from that address and its zone ID. All right. By the way, on Windows, it's optional. So what if I just say ping without the zone ID on a link local address? Windows says, look, I'll use whatever, you know, for me, the most efficient way. If I'm connected to the network wired and wirelessly, typically it will use the wired first. We can't really tell which one it's using. We probably have to look at Wireshark to do this. Okay. Now, what if I gave a bogus zone ID, like %11? You can see request timed out. It says, you know, I'm trying to send a ping out something, but this doesn't exist. Okay, so this is Windows. So to know about Windows, pinging a link local address, the zone ID is optional. Okay, you can specify whether you want the wired or wireless if you have multiple interfaces. Remember, that's what the zone ID is all about, having multiple interfaces. Okay, we'll talk more about that a little later as well. Do I need to use the IPv6 enable command? So let's get back to Cisco iOS for a second. The IPv6 enable command, I used to see this a lot where people, when they thought they had to configure an interface for IPv6, they thought I need to use this command. The answer is no. What is this command used for? You don't need to have it to configure IPv6 on an interface. So it's a little misleading because it's not enabling the interface for IPv6. What it does is, let's take a look, IPv6 enable. And then what if I do a show IPv6 interface brief? What this command does, IPv6 enable, is it will say on this interface automatically generate a link local address, even if you do not have a global unicast address. So let's say I don't want to put a global unicast address on this interface, but I want this interface to generate its own link local address. That's what this command will do. Yeah. Now, can I still add a global unicast address? Yes. And if I remove it, will the link local address still be there? The answer is yes, because once you use this IPv6 enable command, that link local address will always be on that interface. Okay, so let's take an example. Let's take a look at, can I say, can I use just a statically statically or manually configured link local address on an interface? Yes, you can do that as well. This is how you manually enter, and we'll talk about this command more in a moment. If I wanted to manually configure a link local address on this interface, I say IPv6 address, and I give a link local address. How to know it's link local? FE80, then all zeros 99. And you actually have to say link local. Although the operating system knows this is a link local because it's FE80, they require you put this parameter at the end so you know that you're creating a link local address. And if we take a look at show IPv6 interface brief, we can see our address right there. All right, I'm sure I had some notes on here. Here we go. All right. All right, and we'll talk more about the link local address in the next video.